Hello, everybody. Welcome back. Continuing our little discussion on transformations, and there's nothing crazy about it. Last time we talked about the vertical and horizontal shift, and this time we're going to talk about the dilations. And it's a fancy word, but really all it means is you're making the thing appear bigger or smaller. You're really all it is multiplication. I'll be honest with you. So here we go. Right. Let's make a little table. I don't think that's all we need, but just for good measure, let's make one more column. Okay. And all right, good. So, oh no. Okay. So x, good old x. You know what? I did x squared before. Let's do x cubed this time, right? And then let's compare that with 5x cubed. And then let's compare that with, I don't know, x squared, or x cubed, x cubed divided by 2. Okay. All right. So let's pick some numbers. Let's see. -2, -1, 0, 1, 2. That should be enough. If I plug these into the cube, -2 times -2 is 4. 4 times -2, -8. This one's easy. This one's even easier. This one's easy. And then this one is easy too. There we go. 8. Yeah, boom. All right. Now, here, this 5, I'm multiplying by the 5. We can guess what that's going to do. But this multiplication by 5 is what's called my dilation factor. Okay? So in this column, the 5 is the dilation factor. And then in this other one here, x cubed divided by 2, that's 1/2, right? It's like multiplication by 1/2. So 1/2 is the dilation factor for the other one. So I'll just call it dilation factor 2, right? Dilation factor 1, dilation factor 2. Okay, now thankfully we already have the results here for x cubed. So all we got to do is multiply those results by 5. So -8 times 5, -40. -1 times 5, -5. 0 times 5, nothing. 1 times 5, 8 times 5. There we go. Okay. Before we do the last one, let's look at some graphs now. And what I'm going to do... So we got dilation... Let me erase this. Let's do hard eraser. And let's up that brush size, yeah. Look at that. Gone. All right, cool. So now let's do some graphs, yeah. All right. Change my color. Okay. So here we go. So we got 0, 0. Let's see. We got 1, 1. And then we got 2, 8. So 1, 2, 3, 4. Gotta keep going. 5, 6, 7, 8. so 2, 8. Okay, and imagine this is mirrored on the other side. Yeah, so again, imagine it's kind of like that. We're gonna be looking more at this portion than the bottom portion. But now, so now let's see what's happening with this 5. And I'm sure you as you're looking at it, you're probably like, oh, okay, I see what's happening here. So 0, 0 is still there. And now instead of 1, 1, it's going to be 1, 5. 5 times higher. 1, 2, 3, 4, 5. Okay. And then instead of 2, 8, it's going to be 2, 40. And so, if 8's where it's at right now, then 40 would be somewhere way off the screen. It would be something crazy like that. And then something crazy like that, right? So what this is this is like a vertical stretch. Vertical stretch. Okay. Now let's do this last column now. So okay, maybe not that color. Maybe this one. There we go. Okay. X cubed divided by 2. Well, here's x cubed. Negative 8 divided by 2, negative 4. Negative 1 divided by 2, negative a half. 0 divided by 2 is 0. 1 divided by 2 is a half. 8 divided by 2, 4. Okay. So what we wind up with for that one is something like this, and then 4, 1, 2, 3, 4. Yeah, and so this is actually really good at showing us what's happening here. So I divided by 2, and look at what it did. It did like a vertical compression. Vertical compression, or sometimes we call it a horizontal stretch. Okay, and we can see that here with the numbers. And hopefully this is making sense. Let's run through just a quick example without a bunch of numbers. So let's do something like this. Yeah, let's do this. Let's say f is even. F is even. Let's keep that in mind. So f is going to be even. And you know what? I don't need the lines to be that long. Well. Okay, so let's look at f. Let's look at 2f, 10f. Let's look at f divided by 3. Yeah, there we go. And then maybe one more. Maybe f divided by 10, right? Okay. And again, these don't have to be so long. So I'm not going to be filling anything out. I'm just a creature of habit. There we go. Frees up some space. Here's what I'm going to do. I'm going to come over here. And another thing I'm going to do that I should have done at the beginning. I'm going to color code these guys. Okay. So I'm going to keep F green. And then 2F. 2F we can do like this. Let's do 10F in and then let's see, get rid of that, get rid of that, color code. Let's do F divided by 3, and then super blue F divided by 10. Okay. All right. The conceptual understanding is what's really important here. So again, F is going to be in green. There we go, F is in green. Now if I take all the Y values and double them to F, in other words, if I take this Y value and double it, it's going to get higher. If I take this Y value and double it, it's going to get higher. If I take this Y value and double it, it's going to get higher. So 2F, using that reasoning, is going to be kind of like this. Okay. All right. Now, what about 10F, right? Then we're making, so 10F, we're making the Y values 10 times bigger instead of 2 times bigger, right? So let's go ahead and do that. 10F. So if I'm making this Y value 10 times bigger, it's going to be way higher. So it's going to be something crazy like this. 10F will be very vertically stretched. Okay? All right. Now F divided by 3. So think about dividing, right? Think about this Y value, and if I divide that by 3, it's going to be down here. If I take this Y value divided by 3, it's going to be down here, right? So F divided by 3 is going to be below the original F graph. Except for 0, because 0 divided by 3 is still 0. Okay? And then finally, F divided by 10, right? Same kind of idea. If I take the Y value here and divide it by 10, it's going to be way, way, way down here. So F divided by 10, it'll look like this. Okay? All right, so we got our parent function, sort of, in the middle, right? The green. This is my parent function. And, we can see the relative effects of multiplying by different values, by looking at these colors, right? If I divide by a large number, that's going to be a huge horizontal stretch or a vertical compression. It's going to make the function look wider than it actually is, than the original. And then if you multiply by a number bigger than 1, then that's going to do some vertical stretching. Okay? Vertical stretching or horizontal compression, however you want to think about it. It's going to make the Y values bigger. The understanding the fundamentals is so important, right? If you divide by a number bigger than 1, you're making the numbers smaller. If you multiply by a number bigger than 1, you're making the numbers bigger. Okay? And so I think that's all I have to say about vertical and horizontal stretching.